Hello everyone, welcome to our channel. I'm your host Zeb Patty. OpenAI just released a preview of two new models, O1 and O1 Mini. So what is the big hype about these models? What exactly is O1? These are a new class of models, and the name is designed to highlight the fact that they are different in many ways from the classical GPT models like GPT-4 and GPT-4.0 and future series in that line, perhaps GPT-5, etc. OpenAI O1 are not the next iteration of the GPT family. Essentially, we can now expect two different series of models from OpenAI, the O1 models and the classical GPT-4 series. Unlike the other top large language models, or LLMs as they are called, from OpenAI and others like Claude 3.5 Opus from Anthropic and Gemini 1.5 from Google, the O1 series models do not respond to prompts and spit out hundreds of characters instantaneously in a matter of seconds. The O1 takes its time and goes through a process of thinking in a very similar way to what a human would. Humans think before we answer. Well, most of us do anyway. The O1 series introduces a new mode of models. We can call them the thinking models. Let's explain the difference between the traditional LLMs and the O1 by examining the mode in which the models respond to a prompt. As some of you may know, LLMs technically are just next word predictors based on probabilities. LLMs do not think. They are only trained on massive amount of data in order to predict the next word in a sentence. That is why they are very good at generating text, such as stories, poems and essays, etc., but are poor at math and other logic-related tasks. Here's a simple example of how a large language model, LLM, might predict the next word in a sequence. Let's say we have the following sentence. The cat sat on the, and we don't know what comes next. An LLM would analyze the context and probabilities based on its training data to predict likely words to fill in that next word. Its algorithm might generate a probability distribution, for example, like mat, a 30% probability, chair, 25% probability, windowsill, 20% probability, roof, 10% probability, and so on. The model would then typically choose the word with the highest probability, in this case mat, as its prediction for the next word. So the complete sentence it would output would be, the cat sat on the mat. Of course, this is an extremely simplified example of how LLMs work. In reality, LLMs work with much more complex contexts and can generate entire sentences or paragraphs. They also consider a much broader range of words and their probabilities. But as you can see, their algorithm is designed to predict the next logical word in a sentence. Claude 3.5 Opus from Anthropic, Google Gemini 1.5, and GPT-4.0 all fall into this category of models. Now, OpenAI O1 series, on the other hand, are capable of everything that GPT-4.0 does and much, much more. They can actually somewhat think and reason. And this is the real breakthrough. Some folks are calling this breakthrough the first spark of artificial general intelligence. What is artificial general intelligence, or AGI for short? AGI so far is considered a hypothetical type of artificial intelligence that would possess the ability to understand and reason at the same level as a human being. In theory, AGI is anticipated to understand, reason, and perform intellectual tasks comparable to human abilities. In other words, an AGI would be able to perform any intellectual task that a human could. Imagine you're playing a super advanced video game, but the character you're controlling can learn and make decisions just like a real person. AGI is like having a robot or computer program that is at least as smart or even smarter than you, is able to learn anything from playing chess at a champion level to imagining and creating stories, music, making movies, writing computer code, and solving complex math problems. But can AGI be achieved, and can it become a reality? And if so, how soon can AGI be realized? Both these questions are hotly being debated in scientific circles, and there is no common consensus. One main reason for a lack of consensus is in the definition of what AGI really will look like, not in terms of just embodiment, but in terms of capabilities, agency, autonomous thinking, and performing activities. One school of thought is that the primary metrics in terms of what constitutes AGI are economic impact and scientific impact. Embodiment is not necessarily a requirement in order to realize all of the economic gains that we want. There's also the idea, embraced in OpenAI circles, that if you can hire a remote worker and they are as good as a human, that is AGI. One important point to mention here is that even though there isn't a consensus on the term AGI, there is, however, agreement that AGI is not a single endpoint. It is going to be more of a path. We can envision this as first an emerging AGI, then competent, expert, virtuoso, and finally superhuman level. And somewhere in between these levels, embodiment will emerge in order to automate tasks like trash collection, construction tasks, lifeguard, policemen, soldiers, etc. And we'll see appropriate androids and robots for that. Initially, however, AGI will be just a genius set of algorithms equipped with access to massive amounts of datasets and LLMs on the cloud, meaning data centers. OpenAI has been pursuing the goal to be the first to introduce AGI and capture the space. There is strong evidence that in developing O1, OpenAI was inspired by the AlphaGo results and the potential of deep reinforcement learning, or RL. They saw great scaling on RL and robotics, and they figured out how to implement reinforcement learning on a general domain to get to a very capable artificial intelligence. Of course, they already had experienced amazing results of scaling on supervised learning in the GPT paradigm. And so, they combined these two different paradigms into one. This whole effort got started with early explorations with Jakob Uskoreit, Szymon Weitzen, and Łukasz Ilia, all renowned for research in reinforcement learning, multi-agent systems, and adaptive learning algorithms. So OpenAI has been at this for a long time, and since we think there is an ongoing AGI arms race, all the big companies are going to have to respond. Rumors of OpenAI's Strawberry project based on QStar have been floating around recently. QStar with Q-Learning is a genius way of helping AI solve math problems perfectly without any help. Thus, it is not a surprise that OpenAI O1 is exceptional at math. Q-Learning's reinforcement strategies showcases OpenAI O1's potential in precise mathematical problem-solving. Besides building large-scale reliable infrastructure to run the biggest flagship model training runs, as well as doing research experiments, there is something else special about OpenAI, and that is advancements in building synthetic data that is needed for training those models. OpenAI apparently also invested a lot of money in synthesizing a huge amount of data, basically retraining the model on much higher quality data just to begin with. So O1 has improvements in loss functions, has improvements in attention windows, and has improvements in data preparation. All this stuff kind of accumulates and combines to make O1 unique. Just to clarify, many people who have worked with GPT-4, etc., may argue that you can make GPT-4 do complex tasks, or tasks that they argue require thinking as well. That is partially correct because if you are an expert at prompting and know how to use GPT-4, Claude, etc., you can make them do remarkable things. But there is one big difference. What OpenAI O1 series can do in just one well-thought-out response, the classical models would perhaps require dozens of prompts, and this is where algorithmic advancement comes in. OpenAI's genius in algorithmic advancements is also showcased in their O1 series. There are probably three primary techniques at play in O1: chain of thought, Monte Carlo tree search, and reflection. These are all different techniques for either prompting or training language models in order for how to shape their behavior. Before we describe each, let's go over the concept of reasoning, the quality that humans possess but AI so far did not. The ability to reason is one of the main powers that humans have that allows us to function autonomously and make agentic decisions. One way of thinking of reasoning is that there are times when you ask questions and need answers immediately because they are simple questions. For example, if you ask what the capital of USA is, you know the answer is Washington, D.C., and you don't really have to think about it much. But if you want to solve a complex math equation, or you want to write a PhD paper or a fiction novel, you probably want to think about it for a while, and the more you think about it, the better the outcome. So reasoning is the ability of turning thinking time into better outcomes at whatever task we perform. OpenAI O1 is a reasoning model, so it will think more before answering your question. The model is very good, oftentimes better than humans, and as we'll see later in this video, it is equivalent of several PhDs. We'll also later cover why this powerful capability could itself become an obstacle and a challenge in its adoption because of the fear that the model may go off the rails and do something not sensible. Now let's talk about chain of thought. This is a way of training models or a way of prompting models that basically allows it to talk to itself and walk itself through the reasoning steps or problem-solving steps that it will need to provide a better answer. This is essentially a prompting technique that encourages the AI to expose its reasoning process step by step, rather than just providing a final answer. By thinking aloud, the model often produces more accurate and reliable results, especially for complex tasks that require multiple steps of reasoning. Humans do this kind of thinking intuitively. Imagine that you are confronted with a problem that you've never been confronted with before. You are probably going to spend some time thinking first. Your thoughts are going to go into iterative loops, and you are going to mentally assess what you know already, what parts of the problem you are already familiar with, and what is going to work and what is not going to work. This is in essence what chain of thought reasoning is at a very high level. For example, instead of just answering a math problem, a model using chain of thought might write out each step of the calculation, explaining its logic along the way. A lot of stuff is going on under the hood. It is thinking about possibilities, filtering possibilities, verifying possibilities and combinations, evaluating code choices, and a whole lot of other things relevant for an answer. This not only helps with accuracy, but also makes the model's reasoning more transparent and interpretable. You can actually get several orders of magnitude more performance out of models by giving them more time to think, or what's also called inference time compute in AI speak. To reiterate this, inference time is basically when the model is running, rather than just relying on knee-jerk intuition response. The model basically gives a response after thinking through the steps, verifying the steps, and then gives you a response. In traditional or classical LLMs, this type of performance requires building a mega prompt yourself, which is not only time-consuming, but also very tedious and prone to errors. However, with O1, this chain of thought reasoning is native to the model. Next is Monte Carlo Tree Search, or MCTS. This is an algorithm originally developed for decision-making in complex domains, particularly in game-playing AIs. In the context of OpenAI O1, MCTS is most likely used to explore different possible continuations of a text, helping the model to make better choices about what to compute or say next. The basic idea is to simulate many possible future scenarios, like different ways a conversation might go, and use those simulations to inform the current decision. This helps it produce more coherent and goal-directed outputs over longer sequences. Finally, we mention reflection, a technique that involves training the model to critique and improve its own outputs. This process mimics human reflection and self-improvement, allowing the model to catch its own mistakes, clarify ambiguities, or enhance the quality of its responses without external feedback. So the main difference between the two classes of OpenAI models is that O1 is a reasoning-based model with native chain of thought reasoning, while the other classical models require a lot of effort to make them do difficult tasks. We mentioned earlier that reasoning is a human trait that artificial intelligence does not possess as yet, and once that barrier is broken, artificial intelligence would get elevated to an artificial general intelligence or AGI level. OpenAI's breakthrough in chain of thought, reasoning and agentic thinking is a big step towards AGI. With the release of O1 Preview, we have pretty much entered the realm of artificial general intelligence, albeit at a very, very basic level. There are reports of teams that have been using the GPT technology since 2020 and have highly skilled people who spend a lot of time to get the results that you can now get in a single prompt in O1 because of this agentic workflow innovation. Now let's go over some benchmarks that have been used to essentially rate the model's actual performance. MMLU, which stands for Massive Multitask Language Understanding, is a commonly used benchmark for LLMs. In this benchmark, OpenAI O1 has surpassed every model that is out there, and the results are surpassing PhD-level humans. Until today, the MMLU scores for the most powerful LLMs such as GPT-4, Claude 3.5 Opus, and Meta 405B have been stuck in the 87 to 88 range, but the MMLU score for OpenAI O1 series is at a whopping 92.3. About 4 years ago, the scores in the 40th percentile were considered cutting edge. Think of the smartest human in the world. If you have been following the MMLU stats, in 2020, the estimates were that it would take approximately 20 years to ever surpass a score of 90 out of 100. But here we are, just 4 years from the start line at 92.3. A remarkable feat. One way to appreciate the progress is to compare this to the smartest humans. Experts estimate that if you get all of the smartest humans in the world, and they all take the MMLU, that they will get a score of about 89%. The benchmark scores of O1 signal a tremendous potential for this series of models. The actual academic, scientific, and economic impact of O1 is rivaling or surpassing humans in a lot of capabilities. One real-world example reported of this is that O1 Preview, the preview model of O1, was able to do an entire thesis in about an hour, where it previously took an entire year. If this is not significant progress, then what is? Having said that, what are some of the immediate use cases that we can expect O1 to excel in? For one, you can expect O1 being used for coding, debugging, in science and mathematics research, and for crafting solutions for real-world problems. It is going to be a powerful tool for education and learning, because the more one asks it questions about various complex technical subjects, it hallucinates less and explains those concepts better than any previous models. It will also be a powerful brainstorming partner. Because it is able to think before it gives the final answer, it is able to connect ideas better. It will help tremendously those who want to use it as brilliant thought partner to streamline unstructured thoughts. Even though the O1 series lacks some features such as browsing, file, image uploading, and computer vision features, etc. The final release, or a not-so-far-out upgrade, is expected to provide these features and other features to make them more useful to everyone, especially the business sector. The more optimistic experts are of the belief that OpenAI O1 and other future models of this nature will allow many people to have their own businesses and small companies instead of traditional full-time jobs. This is because these models can solve problems, and there are simply too many problems yet to be solved. With the powerful chain of thought reasoning, people will be able to create everything from business plans and business strategies to budgets, operations workflows, and gradually build agent workflow-based AI assistants to run most of the mundane parts of their business. Enterprise adoption of O1 may be a bigger hurdle, and the reason for that is that enterprises are famously risk-averse, especially given the capabilities and strengths of O1 models and their potential to be used inappropriately. But once corporations overcome these fears and realize they are getting agentic workflows, technically at a bargain, we may see faster adoption. You just can't get a smart human to write business plans, analyze spreadsheets, perform audits, read and summarize business proposals, etc., for around $1,000 a month, a price that we believe OpenAI O1 will charge for access to their API and cloud services. This is not cheap, but we can expect Claude, Meta, Google, and even open-source models to introduce chain-of-thought reasoning and agent workflow capabilities, and as models continue to improve, the cost could drop down to as low as $100 a month for fully agentic workflows. Lastly, before we wrap up, we would like to touch upon the discussions around the embodiment of AGI. From the perspective of the AGI, most valuable tasks such as scientific modeling, software development, finding solutions for hunger, disease, global warming, etc., does not require physical presence. All you need is an API and high-speed access to the data center. But for many tasks that are physical in nature, robots will be required. In that case, we can expect the pathfinding algorithm, A*'s relevance, which extends across robotics and AI applications, underscoring its importance in navigating and optimizing decision-making processes. Merging Q-star with A-star's pathfinding capabilities and chain-of-thought reasoning of models like O1 seem a very plausible scenario for embodied AGI. For a lot of people, it's hard to really believe that AGI has arrived, even if technically it is there. This is because until people see robots behaving like humans and do something better than humans can, they will not experience it. So far, we don't have robots yet with human dexterity, so we think there is no need to worry about any pushback from labor unions, at least for the next few years. In conclusion, we can expect the AGI race to heat up if it has not done so already. We can expect Project Orion, which could be GPT next, or it could be GPT-4 from OpenAI, to be released by the end of the year. We can expect Anthropic, Google, and Meta to roll out powerful agentic thinking and reasoning agents sooner than expected. And of course, we can expect open-source models from Mistral and XI, among others, to compete in this AGI race. This first spark of AGI from OpenAI, in form of the O1 series, is certainly going to start a wave of announcements and most likely more regulation by governments and regulators. Keep in mind that this is just one of the paths towards AGI, a path that is based on LLMs, large language models, using transformer-based architectures, typically with reinforcement learning with human feedback, RLHF, to refine capabilities. As artificial general intelligence gets closer to near-term reality, we will surely start hearing about other classes of potential players, such as Yann LeCun's reinforcement learning-based approach, being developed by Meta, and Carl Friston's notion of active inference, being developed by Versus.ai. We hope you enjoyed this video. Please stay tuned to our channel for more content of this nature. Thanks for watching, and we hope to see you again on our channel.